Assalamualaikum and good day viewers. Welcome to this video. We are the fifth group and in this presentation, we will be talking about the chapter 5, Systems Development and Program Change Activities. I am Siti Hafiza Pascan and I will be your first reporter for this topic. So, if you're ready, let's start. A responsive user-oriented information system is one of the most significant assets of a modern company organization. A well-designed system may boost productivity, reduce inventory, eliminate non-value-added processes, improve customer service and management decisions, and coordinate activities across the firm. But before anything else, these are the learning objectives that you are expected to learn after studying this chapter. Be able to identify the stages in the system development lifecycle, be familiar with common problems that can lead to failure in the system's development processes, understand the importance of strategic system planning, have a general understanding of how accountants participate in the SDLC, be able to identify the basic features of both structured and object-oriented approaches to system design, be able to identify and discuss the major steps involved in a cost-benefit analysis of proposed information system, understand the advantages and disadvantages of commercial software option, and be able to discuss the decision-making process used to select commercial software, understand the purpose of a system walkthrough, and finally, be familiar with the different types of system documentation and the purposes they serve. This slide contains the relevant key terms on this topic. I will not hold this any longer, so you may want to take screenshots for your reference. This chapter concludes our discussion of general control issues as they relate to management and auditor responsibilities under SOX Section 404. It describes the roles of system professionals, users, stakeholders in establishing an organization's information system. Then it describes the life cycle of system development, or simply the SDLC. These are systems planning, analysis, conceptual design, system selection, implementation, and program modification procedures, or the system maintenance. Many firms utilize this multi-stage process to guide a system development. Also included are SDLC risk, controls, and auditing. With that being said, the participants in system development can be classified into four broad groups: system professionals and users, stakeholders, and accountants or the auditors. Let's begin with the system professionals. These are system analysts, engineers, and programmers. These people create the system. They acquire information regarding the present problem of the system, assess it, and devise a solution. Their work yielded a new system. Then, the system is built for end users. An organization has many users at all levels. Managers, operators, accountants, and internal auditors are some of the examples. It's difficult to spot a non-user in some organizations. During system development, system professionals work with primary users to understand their problems and demands. Stakeholders are people who are interested in the system but are not end users. These are accountants, internal and external auditors, and internal steering committee that oversees the system development. And then we have accountants and auditors. They address the system development controls, accounting, and auditing issues. Internal and IT auditors should be involved. As discussed in Chapter 1, SOX legislation prohibits external auditors from direct involvement in an audit client's system development activities. And why are accountants and auditors involved in the SDLC? Accountants and auditors are interested in SDLC for two reasons. First, building an information system requires a large financial transaction. System development is similar to any manufacturing process that develops a complex product stages. Planned transaction must be accounted for and regulated. Accountants are concerned about the process's integrity as they are about any industrial process involving financial resources. Accounting and auditing professionals, accountants and auditors, can provide critical input into the system regarding controls, integrity, timeliness, and other important features of financial transaction. The second and more important concern for accountants and auditors in SDLC is the SDLC's output product. The quality of accounting data is intimately related to SDLC process that produces accounting information system. Accounting data is delivered to internal and external consumers. The accountant must ensure that the system have enough controls and follow correct accounting principles. So accountants are quite concerned about the accounting information production process. For example, a wrong SDLC may produce a wrong sales order system with major control defects that inject errors into financial accounting records or allow for the opportunity of fraud. And how are accountants involved in the SDLC? Sorry. Accountants play three roles in system development. First, accountants use. Accounting is impacted by all systems that process financial transactions. Accountants, like other users, must communicate their issues and requirements to system professionals. For example, accountants must specify accounting techniques to be used, internal control requirements such as the audit trails, and special algorithms such as the depreciation model. Second, accountants are part of the development team for system. Their contribution often extends beyond accounting information application development. Indirect financial transaction systems can still use accounting data. The accountants may be engaged for guidance or to assess the system's internal control risk. Professional principles and ethics limit auditor engagement in all circumstances. Then third, accountants serve as system auditor. Accounting software must be auditable. Some computer auditing approaches necessitate special features included into the system during the SDLC. This will be discussed further in Chapter 8 and 9 as we are going to analyze such audit tools. All systems have an auditor's stake and should be designed with auditability, security, and controls. For the information system acquisition, organizations usually acquire information systems in two ways. First, they develop customized systems in-house through formal system development activities, and second, they purchase commercial systems from software vendors. Now, let's go through these two alternatives. Many organizations require systems that are highly tuned to their unique operations. These firms design their own information system through in-house systems development activities. In-house development requires maintaining a full-time systems staff of analysts and programmers who identify users' information needs and satisfy their needs with custom systems. On the other hand, a growing number of systems are purchased from software vendors. Faced with many competing packages, each with unique features and attributes, management must choose the systems in the vendor that best serve the needs of the organization. Making the optimal choice requires that this be an informed decision. Here are the trends in commercial software. Four factors have stimulated the growth of the commercial software market. We have the relatively low cost of general commercial software as compared to customized software. Second, the emergence of industry-specific vendors who target their software to the needs of the particular types of business. A growing demand from businesses that are too small to afford in-house systems development staff. And fourth, large enterprises have been more interested in commercial software because of the tendency toward smaller organization units in the subsequent drive to dispersed data processing. In fact, firms with in-house system development staff frequently buy commercial software as needed. Turnkey systems, backbone systems, and vendor-supported systems are the three types of commercial software. Now, let me introduce to you the types of commercial software. First, we have turnkey system. Turnkey systems are ready-to-use systems that have been fully tested. These are often general-purpose or industry-specific systems. Turnkey systems are frequently sold as compiled program modules with limited customization options. Menu-driven input-output and processing options are available on some turnkey systems. To update the program, other turnkey system vendors sell the source code. For a charge, the user or vendor can modify the system's source code. Then, general accounting systems. They are designed to meet the wide range of user requirements. The The vendor can produce standard system for a fraction of the cost of custom development. Such powerful systems are available for under $2,000. General accounting systems are constructed in modules to maximize versatility. This allows consumers to buy only the modules they require. Financial reporting and fixed asset management are examples of typical modules. Special purpose systems. Some software developers construct the niche solutions for certain markets. Accounting procedures, standards, and traditions in the medical, financial, and government sectors differ from those in general purpose accounting systems. Industry-specific procedures are those dealt with the software suppliers. Office automation systems. Office automation systems are computer technologies that increase employee productivity. Word processing, database management, spreadsheet, and desktop publishing programs are examples of the Office information system. Backbone system. Backbone system gives a foundation for a building system. It includes all primary processing modules pre-programmed. The vendor creates and programs the user interface. Some systems, like Enterprise Resource Planning or the ERP, have components for practically every imaginable business operation, all smoothly integrated into a single system. The buyer can design a highly customized system by selecting modules. A commercial system, however, can be customized. Installing a fully working ERP system normally takes 18 to 24 months and costs $10 million to $100 million. Vendor-supported system. Vendor-supported systems are a mix of bespoke and proprietary software. The provider creates and maintains proprietary systems for its client. The systems themselves are custom, but the service to design them is commercial. This alternative is common in the legal and medical fields. Because the vendor is the organization's in-house system developer, the client must rely on the vendor for bespoke programming and on-site system maintenance. Vendors can build standard modules that can be reused in different client systems by utilizing an object-oriented approach. This method helps decrease client development expenses. So now let's talk about the advantage and disadvantages of commercial software. For its advantage, we have implementation time. Customized systems require time to develop. Internally designed special systems can take months or even years to develop. Long durations or unfilled demand may occur if company fails to foresee future information needs and design application accordingly. However, core identified commercial software may be applied quickly. The end user need not to wait. Then cost. A single user must fully fund internal development. Because of cost of commercial software is shared across many users, the unit cost is a fraction of that of an in-house system. And reliability. Majority of reliable commercial software products are rigorously tested before release. Users will likely find and fix any system's faults not found during testing immediately after the release. However, commercial software is likely to have mistakes than unequal in-house systems. On the other side, the advantages of commercial software are the following. Independence. It is costly to maintain a vendor-supported system. The user runs the risk of vendor discontinuing assistance or going out of business. A vendor-supported system's this is the worst disadvantage. The need for customized systems. The necessity for bespoke solutions. The main advantage of in-house development is precision. These benefits also identifies a flaw in commercial software. Commercial software is sometimes either too general or too rigid for the user's specific needs. Then maintenance. Business information systems evolve rapidly. Modifying commercial software may be difficult or impossible when user needs change. However, in-house development provides users with cost-effective proprietary software. Both in-house development and commercial packages have advantages and disadvantages. They are not mutually exclusive. However, a firm can buy commercial software and develop other systems in-house to meet part of its information demands. Formal procedures give structure to both approaches. Many of its phases, particularly those involving needs analysis and system specification, can be effectively applied even when the final system is obtained from an outside vendor. The objectives and sequencing of SDLC activities are generally acknowledged as best practices by specialists in systems field, but the number of and the names of specific stages within this process are disputed. Various authorities have developed SDLC models with 4 to 14 specified activities. In terms of auditing, the number of actual stages is irrelevant. We are concerned about the process's content and consistency. The figure on this slide depicts 9 stages, but in our textbook, there are only 8 phase SDLC with 2 case stages, the new system development and maintenance. First, all new systems should go through SDLC's first 7 phases. It entails identifying the issue, determining solutions, selecting the best solutions, and lastly, implementing it. Each phase of SDLC generates needed documentation that combined from an audit trail of the SDLC's overall quality. After 7 phases are completed and the system is fully installed, the organization's program change procedures begin. Then, of course, the processes from each stages must be documented. The SDLC steps are summarized here in that we are going to discuss each of them in the following slides. Starting off with the phase 1 of system planning, the objectives of this is to link individual system projects or applications to the strategic objectives of the firm. In fact, the basis for the system plan is the organization's business plan, which specifies where the firm plans to go and how it will go there. In particular, system projects are analyzed by using the IT strategic plan, which is developed from the congruent with the organization's business plan. There must be a congruence between the individual projects in the business plan, or the firm may fail to meet its objectives. Effective system planning provides this goal congruence. Who does the system planning? Most firms that take system planning seriously establish a system steering committee to provide guidance and review the status of system projects. The composition of steering committee may include Chief Executive Officer, the Chief Financial Officer, the Chief Information Officer, senior management from user areas, the internal auditor, and the senior management from computer services. External parties such as management consultants and the firm's external auditor may also supplement the committee. Typical responsibilities for a steering committee include the following: resolving conflicts that arise from new systems, reviewing projects and assigning priorities, budgeting funds for system development, reviewing the status of individual projects under development, determining the various checkpoints throughout the SDLC whether to continue the project or terminate it. System planning occurs at 2 levels: strategic system planning and project planning. Strategic planning involves a macro-level resource allocation. It usually covers 3 to 5 years. Budgeting for other strategic tasks, including product development, facility expansion, market research, and manufacturing technologies, is comparable. As a result, the SDLC does not include strategic system planning. The strategic system plan addresses personnel, the number of system professionals to hire, hardware, the number of workstation, mini-computer, and mini-frames to buy, software, funding for new system projects and maintenance, and telecommunications, the funds allocated to networking and EDI. The strategic plan should minimize excessive detail. Price, performance metrics, scale, security, and control must all be considered in the plan. Why plan strategic system? IT planning is perhaps the most dynamic and unpredictable component of a firm's business activity. Who can reliably forecast 5 years of system technology? Due to this instability, long-term plans are subject to change. So how can a corporation plan a strategic system? And why should it? Strategic systems planning has 4 justifications. First, a changing plan is better than no plan. Strategic plan maps the firm's approach to its IT goal. Planning is superior to winning it in the bash. Then, strategic planning reduces crisis in the system design. A formal plan identifies and prioritizes user needs. So management can plan ahead, identify problems early on, and even predict demands before symptoms of underlying problems surface. In the absence of the strategy, the realization of problem is the trigger. Problems are often ignored until they are reached a crisis point, lowering the quality of the remedy. Strategic planning helps distinguish actual needs from preferences and needs from issues. Third, strategic system planning controls SDLC authorization. Strategic system plan specifies authorization guidelines to guarantee that system development decisions align with the firm's goals. The improper system can be harmful as the wrong plan and equipment. Fourth, system control system planning has historically been a low-cost method of managing system and application development. As to the project planning is used to assign resources to specific applications within a strategic plan. Identification of user needs, preparation of proposals, evaluation of validity, and contribution to the business strategy, prioritization of project, and scheduling of work. Project planning is used to allocate limited resources to specific projects. The project proposal and the project timeline are the outputs of this phase. We have the project proposal. This helps management decide whether to proceed or not, derived from a formal proposal. A general recommendation for a new or updated system is first summarized in the report. This allows management to assess the problem and the suggested system as a solution. Second, the proposal outlines the link between the proposed system goals and the firm's goals, particularly those specified in the IT strategic plan. It illustrates that the new system complements the firm's strategic direction. Then we have the project schedule. This shows management's dedication. The project schedule is a time and cost budget for all SDLC phases. These phases will be completed by a project team made up of system experts and users, accountants, and internal auditors. The team's composition, expertise, and dedication are vital to the new system's success. What are the auditors' role in system planning? Simply, auditors routinely examine the system planning phase of the SDLC. Planning greatly reduces the risk that an organization has produced unneeded, inefficient, ineffective, and fraudulent system. Therefore, both internal and external auditors are interested in ensuring that the adequate systems planning takes place. We're now moving on the second phase in the SDLC. First, a survey of the current system is conducted, followed by the needs analysis of the users. Before recommending a solution, a system analyst must completely comprehend the business issue. A wrong analysis leads to a wrong solution. So system analysis in the SDLC is the SDLC's foundation. The phase produces a formal system analysis report with findings and suggestions for the new system. The survey step. Most systems are not developed from scratch. Usually, an information system and procedure are in place. The analyst often starts by deciding which components of the current system should be kept in the new system. This requires a thorough system survey. The preliminary system facts are acquired and assessed. As the analyst gains a deeper grasp of the problem, more specific questions arise for which additional information is required. This technique may be repeated numerous times. After gathering and analyzing all pertinent data, the analyst assesses the current system. Surveying the current system has both advantages and disadvantages. Starting off with the disadvantages of surveying the current system, current physical target. This term is used to describe the tendency on the part of the analyst to be sucked in and then bogged down by the task of surveying the current dinosaur system. And thinking inside the box. Some argue that current system survey stifle new idea. By studying and modeling the old system, the analyst may develop a constrained notion about how the new system should function. The result is an improved old system rather than a radically new approach. For the advantages of surveying the current system, we have identifying what aspects the old system should be kept. Some aspects of the old system may be functioning and can be used to build the new one. With a thorough grasp of the current system, the analyst can determine what should be kept or changed. And then forcing system analysts to fully understand the system. That's for another advantage. With the new system, when the new system is implemented, users must convert from the old system to the new one. The analyst must decide which jobs, procedures, and the data will be phased out and which will be kept. To design this conversion technique, the analyst must know both the new system, what the new system will do, and what the previous system did. This necessitates the thorough knowledge of the present. And another advantage is isolating the root of problem symptoms. An analyst can pinpoint the sources of a problem by assessing the current system. This may be a management or personal issue that can be addressed without altering the information system. It's possible that we won't find the root cause if we just trust the old system without investigating the symptoms. Gathering facts. The survey of the current system is essentially a fact-gathering activity. The facts gathered by the analyst are pieces of data that describe key features, situations, and relationships of the system. System facts fall into the following broad classes. Data sources. These include external entities such as customers or vendors as well as internal sources from other departments. Users. These include both managers and operators users. Data stores. Data stores are the files, databases, accounts, source documents used in the system. Processes. The processing tasks are manual or computer operations that represent a decision or an action triggered by the information. Data flow are represented by the movement of document and reports between data sources, data stores, processing tasks, and users. Data flows can also be presented in UML diagram. Controls. These include both accounting and operational controls and may be manual procedures or computer controls. Transaction volume. The analyst must collect a snapshot of transaction volumes across time. Many systems are replaced due to capacity. Understanding a system transaction volume and growth rate is critical to determining future system capacity requirements. Error rates. Transaction errors are closely related to transaction volume. As system reaches capacity, error rates increases to an intolerable level. Although no system is perfect, the analyst must determine the acceptable error tolerances for the new system. Resource cost. Existing system uses labor, computer time, materials such as the invoices, and direct overhead. Escapable costs are source costs that evaporate when the present system is removed. In the latter cost-benefit analysis, escapable expenses will be considered as new system benefit. And finally, bottlenecks and redundant operations. The analyst should identify bottlenecks in data flow. During peak loads, these might cause delays and processing mistakes. Duplicate processes such as approvals or sign-offs can also cause delays. A system designer can avoid repeating errors by identifying trouble areas during a survey phase. Systems analysts employ several techniques to gather the previously cited facts. Commonly used techniques include observations, task participation, personal interviews, and reviewing key documents. Starting off with the observation is passively viewing the system's physical processes. This helps the analyst to decide what gets done, who does it, when, how, why, and how long it takes. Task participation is a participation in an extension of observation when the analyst actively assists the user. This allows the analyst to directly feel the present system's issue. On a sales desk, for example, the analyst may take note and prepare customer orders. The system analyst can, can detect if paper are poorly prepared, if procedures are not completed on time, or if peak load issues generate bottleneck and processing errors. Having done the job, the analyst may often see better methods to do it. Personal interviews. Interviewing is a way to get information about the current situation and user expectations from the future system. Open-ended questions and formal questionnaire might be used to collect this data. The open-ended questions allow users to elaborate on the issue and make recommendations. These questions are tough to answer, but they help the analyst understand the problem's scope. The analyst must also be able to focus on the important details and listen well. What do you think is the primary issue with our sales order system, and how could the system be improved? Questionnaires are used to ask more specific questions and limit user responses. This is a good way to obtain data on procedures, transaction volumes, data sources, and report users and control issues. Reviewing key documents. The organization's documents are another source of facts about the system being surveyed. Examples are Examples of these include the following. We have organization charts, job description, accounting records, charts of accounts, policy statements, description of procedures, financial statements, performance reports, system flowchart, source documentation, transaction listing, budgets, forecasts, and mission statement. Now, for the second step in phase 2, we have the analysis step. System analysis is an intellectual process that is commingled with the fact gathering. The analyst is simultaneously analyzing as he or she gathers facts. The mere recognition of a problem presumes some understanding of the norm or desired state. It is therefore difficult to identify where the survey ends and the analyst begins. The system analyst report. The formal system analysis report concludes the system analysis phase. This report informs management or the steering committee of the survey results, system issues, user needs, and system requirements. The main goal of a systems analysis is to discover user demands and provide system requirements. The report should explain what the system must accomplish, not how it must do it. The report's requirements statement clarifies expectation for system experts, management, users, and other stakeholders. This document is a formal contract that defines the system goals, information on data sources, users, files, and general processes should be included in the system analysis report. On the left side is the possible report format. The system analysis report does not detail proposed system design. It does not describe processing methods, storage media, record structure, or other physical system characteristics. As a result, it does not impose artificial limits on the conceptual design process. The development process must be open to explore all feasible designs that meet the user's needs.